Hey folks, Mr. Dell here. We are looking at a equation that has already been solved and trying to find the error, trying to find what mistake was made. Error analysis. So this is a problem I'm taking from CPM's course 3, section 6.2.1, specifically number 6-49. It says when Ms. Shreve solved an equation in class, she checked her solution and found that it did not make the equation true. Examine her work below and find her mistake. Find the correct solution. So if we're looking at, this is the original equation. 5 times the quantity 2x minus 1 minus 3x equals 5x plus 9. So I usually like to put the line down the middle because, again, what you do to one side, you do to the other. So it kind of makes sure we see that equation, that equal sign. So if I look over and I see what she did, first of all, she is starting to simplify this side. So distributing that 5, basically, take that 5 and multiply it through. So 5 times 2x is 10x. 5 times 1 is 5. So it's 10x minus 5. That is correct, minus 3x. So far, so good here. Then the next step down, combining like terms, 10x minus 3x is 7x. And then the minus 5 stays. That can't be combined. So far, so good on this side, all the way down to this step. We're good. But then on this side, 5x plus 9, 5x plus 9, nothing's changed because there's nothing to do here. So we're good all the way down here. So now what did we do here? What did she do, or what should she have done here? If we're looking at trying to get all my x's on one side and all my numbers on the other side, what I see is she's got 12x. Where did 12x come from? What it looks like is she added 5x plus 7x. But is that what we would do? No. To if we added 5x over here, 5x plus 5x doesn't cancel, it stays 10x. So what I needed to do, so this is where the mistake happens, and this is where I'm going to rewrite what she has and do it right the first time. And then I'll write with the mistakes. So what should have taken place is, instead of adding 5x, it should be a minus 5x, because we want to get rid of the x's from one side. Isolate the variable term by getting rid of x's on one side. So subtract 5x, and therefore you subtract 5x from this side. So when you do that, you have 7x negative 5x, or 7x minus 5x. This should become a 2x, right? And then over here, looks like she got rid of the 5. The minus 5 is gone, but how did she do it? Well, it looks like she took the minus 5 and the positive 9 and just combined them to get 4. But what needed to happen was the opposite of minus 5 is plus 5. So that minus 5 plus 5, that cancels on this side. And what you do to one side, you do over here. So really what should have been over here was a positive 9 and a positive 5 is a positive 14. So she didn't do the opposite operations, the inverse operations on this step. She just combined both sides, which is not what we got to do. We have to eliminate by doing opposite operations. So there's where I'm going to put my response here. So right here, she did not. Oh, here we go. Did not use opposite. She did not use opposite operations to eliminate terms from each side of the equation. Okay, so she did not use opposite operations to eliminate terms from each side, I should say side, of the equation. So that's the fix. That's how we should do it. And then the last step here would have been to divide by the coefficient, right? To get that x all by itself, you divide by 2. 2 divided by 2 gives me that 1x. And then 14 divided by 2 is 7. So the correct answer should be x equals 7. not x equals 1/3. All right. There we go.